Here we have a GRE question dealing with greatest possible value. We were told that in the expression, A, B, and C are different numbers, and each is one of the numbers 2, 3, or 5. What is the greatest possible value of the expression? First thing you want to do all the time is simplify the expression if you can. So we have a pretty complex fraction going on. So I'm going to identify the two parts of the fraction here. And as you recall, I'm sure you cannot divide fractions. So we're going to go ahead and do keep, change, flip, where we keep the first term. We change the division into a multiplication. And then we flip the second term. So we are done with this now. And we are going to now distribute our flipped term to each part of the first half of the fraction, which would give us AB over BC plus BC. Now, notice if we multiply the second fraction by a b over b, which would be equivalent to 1, we would then have a common denominator and we could add the entire fraction up as one fraction and solve it that way. So let's go ahead and do that. So we're going to multiply this side by b over b so that we can have a bc denominator. That gives us AB plus b squared over bc as our fraction. And now we want to plug and chug. We have 2, 3, and 5 as our options. So we're thinking to have the greatest possible value, we want the smallest possible denominator and the largest possible numerator. That means that our smallest value we want to put with c since it's solely on the bottom. So we're going to make c equal to 2. That leaves us 3 and 5. Well, if we put a 3 for b, then that means our denominator is 6. So let's just take a look at that. If we have 3 for b, that means we have 6 on the bottom, and then 5 would be a, so 3 times 5, so we'd have 15, plus 3 squared plus 9, which would give us 24 over 6, which would be equal to 4. You might be tempted to plug in 5 for b because of this b squared. So let's take a look at that as well. That means we'd have 5 times 2 on the bottom, so we'd have 10 as our denominator. But then we'd have 5 times 3, so 15 here, and then 25 on the top, giving us, here we go, giving us 40 over 10, which also gives us 4. So in this case, it works out either way, as long as our c is the 2 value, and that means 4 is our final answer for the greatest possible value of the expression.